I am audible? Hello? You can write in the chat box also. So we will start within 5 minutes. Let us wait, maybe another student will join. Hello Shiv Shankar, I am audible? Please just confirm whether I am audible or not. Hello?
Good evening, sir.
Yeah, very good evening. So slide is visible. Week number 2, fluid mechanics.
Yes, sir.
Okay,
Week
thank
2 Fluid Mechanics Live EA
Okay,
section. Yes,
okay,
sir.
okay, good, fine. So now we'll start. So let us start. So the topic for your week number 2 is lecture 1 was about the concept of fluid hydrodynamics, and second one was about the measurement of fluid pressure and fluid hydrostatic force, and third was about the buoyancy, metacenter, stability and rigid body motions. So actually I have covered a lot of questions. These are the questions your the previous year, the same session, the PMRF NPTL live session. So for this year I have lot of new questions. So these are the questions I'll upload. If anyone have doubt regarding these questions, you can ask in the next class. So let us start with the new questions. So this is your first question. The first question is about the pressure at a depth of 15 meter under water surface in a dam is approximately. So the 15 bar, 1.5 megapascal, 150 kilopascal or none of the above. So which option will be correct for this question? So please everyone just try to solve and write your answer in the chat box. Everyone please try to write. I am waiting. I will give you 2 minutes. Then after I will discuss. So please everyone write your answer in the chat box. So everyone please write. Anyone can write. Yes, anyone can write your answer in the chat box. Very simple question, please. So anyone?
No, sir.
Okay. So let us. Okay, the question is about the pressure at a depth of 15 meter. So let us. You have the water level like that, and this is the bottom. Under the dam, it is asking about. So let us assume the dam is like that. Okay. So let us suppose here is a 15 meter. So this much is your 15 meter. So here asking about the pressure. So as you know, using the hydrostatic pressure law, pressure is equal to rho gh. Now everyone can solve. Now please tell your answer. Rho means rho of water, that is 1000 kg per meter cube, and g is your, you can consider here 10 meter per second square, and h is given. So now I want answer from your side. Okay, the set is telling 1.5 megapascal. Okay, good. Other student, please also try to write your answer. Now you can calculate.
Do you, none of the above?
Okay, you are telling none of the above. Okay, other student, please also. Then after I'll show you the answer. So please everyone try to participate. No one? Okay, let me just show you the answer. So answer is here 150 kilopascal. How? So let me just show you. So P is equal to rho GH. So rho is here 1000, G is your 10 as I was telling, and H is your 15. So means 15 into 10 raised to 4. So here you can write 150 into 10 raised to 3, or this is your pascal, this is also pascal. So for kilo 150, this will convert in K pascal. So hope you all got it. Now we'll move on the next question. The next question is, which of the following related fluid flow parameter existing both in rotational and irrotational flow? So your vorticity, stream function, velocity potential, and both vorticity and stream function. Which option will be correct for this? So before moving this question, I have very interesting question regarding that. So let me just show you. Yeah, this is the question. Yes. Oh, this is the question. Question. So here you have the lot of point A, B, C, D, E, F, G, and another also H and I. You have the lot of years. So lot of points. So the option is option A. Just focus on whatever I am writing. The option A is pressure at A is equal to pressure at H. Option B, pressure at H is equal to pressure at I. Option C, pressure at A is equal to pressure at B is equal to pressure at C is equal to pressure at I. And option D, none. So which option is correct? Just try to think on that. Which option is correct for this figure? So this is also related to your hydrostatic pressures. So try to think on that and try to write your answer. Which option will be correct about these four options? So P is stand here for pressure, A is for point A, B, C, D. So now you think on that and try to write your answer in the chat box. Please everyone. Okay. So please anyone just try to write your answer in the chat box. Which option will be correct regarding the figure? The similar from your previous. If you will think about the how H is varying and your density, so you definitely are able to give the answer. So please just try to think on that. This is a very important question. Okay, let me discuss. So your answer, what answer will be correct? So as I was discussing previously, your pressure is equal to hydrostatic pressure rho gh, as you know already. So rho means here of liquid. Here we are considering the liquid or fluid, you can say, and h is the height. At A, that is PA, your pressure is rho G, rho of water. If this is water, then we can write here water. G H, the height is H. At pressure at H, how much? Rho of mercury Hg. G will be constant for all, and H also varying, as we, that is the H plus something. Something means, let us write here delta Y, because H height is up to that much only. After that, this much height. So this is wrong. This is not correct. Now come here. pH is equal to rho G, this one, and Pi is rho of water G, and height is same, H plus delta Y, because height is same from the hairs. If you will see, the height at I and height at H will be same, so you can write this, but here the density difference is there, rho water and here rho Hg, so this is also wrong. Now come on the C, Pa rho Gh, this is correct, and the level is same, so rho of water G H, Pb also will be equal to this, but Pi is different, so option C is also wrong, so option D will be correct, none. So remember please how you will calculate the things, that is the hydrostatic pressure, your density matter and height matter. Remember, this is a function of your density and height. Remember always hydrostatic pressure. So now let us move on the question, next question. The next question is about, yes, already we have seen, yeah, this is the this was your next question. Which of the following related fluid flow parameter exist both rotational and irrotational flows? Vorticity, stream function, velocity potential, both vorticity and stream function. Which one is correct? I need answer from your side. Please try to write your answer in the chat box. Everyone please. So everyone please try to write your answer.
Velocity potential.
Okay, you are telling the velocity potential, good. Other student please also try. Whether you will wrong or right, there is no matter here. This is not your exam. Just we are discussing the questions, lot of questions. So remember these things. Just your apply mind and think on that. What is stream function and just I'm giving you hint. uh, Here we, okay, you are telling, the Pramod is telling a stream function. Okay, other student, please also try and write your answer in the chat box, because this session designed especially for you guys. Okay, verticity 1:20 is telling, Bhavna is telling verticity. Okay, okay, let me just show you the answer. So remember please, here the option will be the stream function, yes, but how? This is also very important, how it will be the stream function. So let us first discuss about your velocity potential function. So you know already, velocity potential, the function is, the u is related, that is the velocity potential function is related with your u and v, that is the flow in streamwise direction and lateral direction. So u is equal to minus del phi by, that is phi here is the potential function, and del x. Similarly, v is equal to minus del psi by, del phi by del y. So this is the, but here if velocity potential exists, the flow should be irrotational. The condition is, if the potential function exists in a flow, that flow should be irrotational. Remember, if the velocity potential satisfy the Laplace equation, if the velocity potential function satisfy the Laplace equation, it represents the possibly steady incompressible irrotational flow. Remember, here we have the two conditions for check whether the flow is rotational or completely rotational or irrotational. So one is Laplace, another is whether it is exist or not. So if it is exist, so flow is irrotational, yes, this is correct. And if Laplace equation also satisfy, it represent the possibly steady incompressible irrotational flow. If Laplace equation will be satisfied, means flow is irrotational. So question is about here, the fluid parameter exists in both rotational and irrotational flow. Another is your, the next one, the stream function. Stream function is this, u is equal to minus del psi by del y, and v is equal to del psi by del x. So here is the condition, if the stream function exists, the flow may be rotational or irrotational. The question, it is linking with your question. Here question was about both rotational or irrotational, but the potential function if exists, only irrotational is possible. Remember please, only irrotational is possible. Remember, if the potential function is exists, only irrotational is possible. But here, if it is exist, may be rotational or irrotational. Yes, it may be the both rotational or irrotational. This is the condition. Second one, if stream function satisfy the Laplace equation, it represent the irrotational. Okay, so both, if Laplace equation satisfy whether potential function or stream function, it represent the rotational function, but stream function if exists, it may be the rotational or irrotational. So the best appropriate here answer is stream function. Always remember please, this possible, this can exist in both irrotational or rotational flow. Always remember. And what is vorticity? Define the value of twice of the rotation. The vorticity is the twice of the rotation. Always remember. Let us move with the next question. Any fluid flow follow Bernoulli's equations, Newton's law of viscosity, Darcy's equation, continuity equation. Which option is correct for this question? Any fluid flow should follow. Which option is correct? Please everyone try to write your answer in the chat box. Or you can just tell me also using your mic. Otherwise you can write in the chat box.
Bernoulli's equation.
Okay. Okay. So
continuity equation.
continuity equation, Pramod is telling.
A and D.
A and D, you are telling both. Okay. Bernoulli's equation and continuity equation. Okay. So here we are talking about, just remember, focus on the question, any fluid. We are not specifically talking about any kind of fluid, any fluid. It may be your honey, it may be your water, it may be your air, whatever. So think on that, whether Bernoulli's equation applicable for all kind of fluid, Newton's law of viscosity is applicable for all kind of fluid, Darcy's law or continuity equation. So just try to write your best in such type of question, multiple choice questions. Always try to select best appropriate. So we are talking about the general question. This is a general question, but yes, I am appreciating who has approaching, who has specifically who approached this question. Try to think about this, whether which option is correct. Yeah, I am really appreciating. Whether you wrong or right doesn't matter here. Remember these things. So okay, okay, let us discuss. So here we are talking about the fluid, any kind of fluid. So remember one thing, the mass balance should be, mass balance mass balance should be followed by all fluid. That is mass in equal to mass out. So that is your continuity equation. Remember please. Always remember. Maybe your fluid may not follow this Newton's law of viscosity. As you know already, the Newton's law of viscosity is what? Tau is equal to mu du by dy. But for Bingham plastic and other kind of fluid, you write this one, mu du by dy plus b or something power like that. This is not your Newton's law of viscosity. So this is not mandatory rule. All fluids should follow the Newton's law of viscosity. All fluids should follow Darcy's law continuity. But this is a mandatory rule. All fluids should follow the continuity equation, that is mass in and mass out. So this is a basic question and fundamental question. Now we'll move on the next question. The
Sir,
yes.
again repeat, sir. Option who is correct, sir?
Okay. So which option is correct? Let me just repeat.
A and D.
No, no, no.
Only D.
Only D is option is correct. Let me just repeat
Okay, sir.
again the
Okay,
whole
sir.
concept. So here concept is we are talking about the only fluid, the any kind of fluid, not your specifically we are talking about water here. So the any kind of fluid should follow the mass in and mass out. Mass in and mass out. As you know already, the like the as we have studies already, some fluid follow the Newton's law of viscosity, some fluid follow the non-Newtonian fluid, you know already. So this is not mandatory rule. This will follow, this will follow, this will follow, but this is mandatory rule. The all fluid flow should follow the continuity, whether it may be the gas or it may be the liquid. Next question is, which of the following statement is more relevant? More relevant means which one is correct? Just try to think on that. First one is, in kinematics of fluid flow, the pressure is a vector field. Option B, that is option 2, in a Lagrangian approach, a fluid particle is fixed, mass is considered. Third one, the fluid kinematics deals with the action of the force in producing or changing motion of fluid. Option D, in the Eulerian method, control volume approach is not used. Which option is correct for this? That is the most appropriate statement. Means the which one is correct. Everyone please try to think on that, or you can write your answer in the chat box. This is A, this is B, C and D. Which option is correct? This is very important question. This question is also from your very beginning. Sir has already told you not. I think in the first week, this type of questions, this type of concepts are teach you already. So think on that and try to write your answer. Which option is correct? A, B, C, D.
B and C, sir.
B and C. You are telling
Okay,
two.
sir.
Okay, good. Okay, nice approach. And Pramod is telling C option. Okay, that is the fluid kinematics deals with the action of force in producing or changing motion of fluid. Okay, so anyone want to tell? Just please, I'll give you 1 minute more. Read very carefully the question and try to write your answer in the chat box. You have 1 minute more. Then I'll show you the answer, or little bit I'll discuss here. This is very important question. Okay, let me discuss. So yes, your option here is B is correct only. The Lagrangian approach, a fluid particle of fixed mass is considered. Here in the fluid kinematics, actually in fluid dynamics, you consider the action of force. Remember, please, in fluid dynamics, not kinematics. In fluid kinematics, of the pressure is a vector field. This is also not correct. And in the Eulerian method, control volume approach is not used. No, in control volume approach is used. Here is the correct. Or this is also wrong because here not is given. So let us discuss about here two things. One is the your control volume approach. Control volume approach, that is the Eulerian approach. And another is your fixed mass approach. Means this is your Eulerian approach and this is your Lagrangian approach. So what is Lagrangian approach? Let us discuss first. Let us suppose you have a river, flow of river like that, and water is flowing in this direction. You want to measure some velocity, the what is the velocity of the fluid. So you have instrument, let us suppose this is your instrument, and you have just thrown the instrument in the river, just thrown the instrument here in the river, and your instrument is moving with the same fluid particle. Whatever the fluid particle was here, your instrument is also moving with this. Means your instrument is tracking a particular fixed mass. Your instrument here is tracking only a particular fixed mass. So such type of approach is known as Lagrangian approach. What is happening in the Eulerian approach? Similar, if you have, let us suppose, river again, in Lagrangian approach you will fix some volume. You will fix the volume, control volume, and you will measure on this. What is happening here? There is no, the fluid is in and fluid out. That is the mass in and mass out is happening here. But here is no. You are working with only the similar fluid particle, not fluid. The fluid identity also not change. Identity means here, if you are, let us suppose here millions of the fluid, but here you are measuring only the one number of fluid. Also the here you will also measuring the one number, not nothing other. But here the fluid is entering, millions of fluid entering, millions of fluid is going out. So such type of this approach is known as the Eulerian approach, and both approach is used for what? Used for deriving the formulas, deriving your physical phenomena in terms of mathematics. Deriving the physical phenomena in terms of mathematics, this both approach is used. So always remember, and what is Lagrangian and what is Eulerian. So usually in the fluid mechanics at your we use this Eulerian approach. And the all, one important thing also here, the all your formulas, whatever the basic fundamental formulas, Newton's law of motion, and all these things derive based on this one. The Newton's law of the, that is F is equal to ma, is derived based on your Lagrangian approach, not for the. But when you will use in the fluid mechanics, you need to this convert formula for your Eulerian approach. This Lagrangian approach formula you need to convert in the Eulerian approach, and for this you will use RTT, Renault transport theorem. So this is bit advanced things. Hopefully you will get in the coming classes what is Renault transport theorem. So but here is the some basic thing is, from Eulerian approach, when you will convert your formula from Lagrangian to Eulerian, you need RTT, that is a Renault transport theorem, and your basic fundamental formulas is derived for the Lagrangian using the Lagrangian approach, not the Eulerian approach. So hope you all got it. So here is some the concept is given already, some written document is given, explanation and all. So we'll move on the next question. The pressure intensity at a point, we are talking about here the pressure intensity at a point in a fluid is the same in all direction. Only when the fluid is frictionless, the fluid is frictionless and incompressible, the fluid has zero viscosity and is at rest, has no relative motion between adjacent fluid layers. Which option is appropriately correct for this question? Please everyone try to write your answer. This option is A, this is B, and this is C, and this is D. So hope you all got it, previous question concept, the control volume and control mass and control volume. You can say this fix, this one, the fix mass, you can also say the control mass approach, control volume and control mass. Okay, by the way, you just try to write the answer for this question number whatever, the question number here not written. So please everyone try to write your answer in the chat box. Very important question. As we have discussed in the previous class, the junior the study class, we have discussed already such type of concept. So if you have remember, just think on that and try to write the answer. Already we have discussed. Once I'll discuss, I'll recall your previous concept, then I'll move on this question.
Only B.
You are telling option B, frictionless and incompressible. Okay. Other student, please also. Okay. The okay. B. You are telling the B. Seti is telling B. Okay, good. Other student, please also try to write your answer. As you have joined here, it means you uh, the meaning of this class is, if you are not participating in your in the chat box or in your question answer session, so there is no meaning. Whatever you are in your mind is coming, you just try to write. Pramod is telling option D. Okay. Viscosity index. What is viscosity index? I know the viscosity, but what is viscosity index? I don't know. Okay, I'll see. I look about the viscosity index and I'll discuss in the next class. Thank you for your questions. Definitely, I'll discuss in the next class viscosity index. Oh, Nitish is also telling option B is correct. Okay, good. So, one thing is the pressure intensity. Remember, pressure intensity at a point. Let us suppose you have the okay change in viscosity with change in temperature. Okay, okay. So you are telling these things. Okay, I can discuss. Okay, I'll discuss after this question these things. So let us suppose you have the water here and we are discussing about at a point. Let us suppose this is the point P, and here the pressure intensity at a point in a fluid is same in all direction. That is, the pressure in all direction is same. Means if here is 10, everywhere is 10. The meaning of the question is only when this is possible, only when the some student is telling B, someone telling C, but the correct answer is has zero viscosity and is at rest. Means zero viscosity means what? Zero viscosity means ideal fluid, and in rest you know already the velocity will be zero. So the in previous that is yesterday I was dealing with this condition is possible when your shear stress will be zero. So in this case the velocity will be zero at rest, and in zero viscosity mu will be zero. So definitely in both case, if this is zero then tau will be zero, if this is zero then tau also will be zero. So this is your most appropriate and correct answer for this question. Okay, now let us move with the next one. Okay, let us discuss about one student is asking about the viscosity and temperature, that is mu and temperature. So let us discuss for liquid, means water. I am considering here for example water. So as your viscosity will increase, just I'll write the relation between mu is directly inversely proportional to 1 by T. Means in case of liquid, if temperature will increase, the viscosity will be decrease. And why the viscosity, why it is decrease? Because the molecules, as I am here taking the example of water, that's why I am writing here water. The water molecules, the
Internal energy of the molecules is reduced.
yes, that thing I am going to tell you. So in a very simple way I want to tell you. Yes, that is good one. So the water molecules, what will be happen? So if this is, let us suppose initially without any increasing the temperature, the water molecules, the distance between the molecules was like that. So after increasing the temperature will be little bit away. So means the energy, internal molecules, that is the attraction force, that is we are previous in the study class we are discussing about the cohesion and adhesion. So cohesion force will be reduced. So that's why this is happen like due to this reason. And in case of gas, so in case of gas what will happen? Just directly proportional relation temperature with this. As your temperature will increase, the viscosity will be increased. Why? In the gas actually you have the lot of space. Already you have lot of space in the fluid, but as your temperature is increased, the random motion of the particle is increased, means the friction is increased. If the random motion will increase within the your gas, what will happen? The friction between the particle will be increased. So that's why your this, ultimately what is this mu? This mu is the friction. So in the general way I am telling. So option, not here the option. So this is the concept about your mu and T relationship, temperature and dynamic viscosity, dynamic viscosity. So now let us move with the very interesting questions. Such type of questions you can expect in your exam also, because this is the instrument and use. So match list 1 and list 2. So list 1 is your device and list 2 is your what is the use of the device. So barometer, gauge pressure, hydrometer, local atmospheric pressure, U2 manometer, relative density, and the your down gauge is the pressure difference. So which option is correct? Whether A, B, C, D. So let me write here small a, small b, small c and small d. Already capital A is used here. So which option is correct? Please everyone try to write your answer. Very important and very easy questions you can say. Option D is telling Nitish. Okay, good. Other student please also try to write your answer. This is very important question. Okay, D. Sasti is also telling D. Pramod is telling D. Okay, most of the student telling D. I am considering here. So you all in favor with D. So let me just the hydrometer. So what is the use of hydrometer? What is the use of barometer? I know very difference. The barometer is used for pressure difference. So A will go with your, oh no, barometer is not. Your hydrometer, yes. Your hydrometer is used for what?
Relative
Whether
density.
relative density. Okay, so okay, good. And U2, the U2 manometer is your gauge pressure. So I am very sure about your C. So C is with 1. So I'll go with the C is 1. The gauge U2 manometer is used for the gauge pressure, not gauge pressure. Oh, I am doing something wrong. For the pressure difference, the gauge
Then
pressure
more
is
than
used.
more than
Yes,
gauge is used for
this
gauge
is
pressure.
used for your pressure difference, I think. U2, this one, YouTube manometer, used for the pressure difference, because what we do in YouTube, just for your clarification, let us suppose this is your one pipe and it is connected like that, and some, let us suppose here water is flowing and we fill here the mercury and kind of things. This is A and this is B. So from here you two we consider, we find out actually the pressure difference. So remember from here this. So option C is go with the 4. So you have only two one, whether it may be the C and it may be the D will be correct. So now let us find with the for D, option A will be, option 1 will be correct. And now let us find for B or A. For B, that is your hydrometer. For hydrometer is used for your relative density. Remember please. And barometer is of course is used for the atmospheric pressure. So this the approach should be like that. So yes, option D will be correct. So now here is given already. A hydrometer is used to find a specific gravity and relative density of the liquid. Barometer is used for the local atmospheric pressure. U2 manometer is used for the pressure difference, and your Braun gauge is used for the measure the gauge pressure. Always remember please. So now a very small numericals. Typical ice peak in a polar region has its peak above the sea level. Remember, peak above the sea level is given here, but the large part of it is floating beneath the sea. Large part is floating beneath the sea. Consider the peak as a ice block whose 5-meter portion is above the sea level. Determine the height of the block below the sea. You need to find out the block below the sea, and the specific gravity of ice is given 0.9, and a specific gravity of the sea water is given this 1.028. So now please everyone find out the height of block below the sea. So I am going to write height of block below the sea. So you need to find this one. Everyone please try to solve this question. You have 5 minutes. Within 5 minutes, please everyone try to write your answer. Very important question. Such type of question you expect in your GATE exam or final exam of NPTEL. So please everyone. Very important questions. So after this question, I'll take 5 minute break. So you guys also go for 5 minute break, then we'll come back. So first we'll solve this question. So anyone solving? Okay, you have time 2-3 minutes. Just try to solve. Then I'll give you a hint or I'll solve the question. Okay, okay, fine. If you have work, you can leave. The video is, I am recording the video, so I'll upload on YouTube. You follow the video. If you have any doubt, you can ask in the next class. Okay, thank you. So, anyone want to tell? Okay, let me just discuss. So, let us assume this is your sea level. This is your sea level. So here question is, you have one ice block which is 5 meter portion is above the sea level. 5 meter above the sea level. This is water. This is your 5 meter. And this is ice, remember. Okay. If this is 5, maybe this height will be this one. H, height of block, right? So this is you need to calculate. But how? Yes, another thing is the specific gravity of ice is given. Zero 0.9, and the specific gravity of the sea water is given 1.028. So from here you can calculate the rho, that is the density of sea water, 1028 kg per meter cube, and from here you can calculate 900 kg per meter cube of rho of ice. Okay, so now you need to calculate this one. So as per your the law of buoyancy, the Archimedes principle, so what is your buoyancy force will be equal to how much? buoyancy force will be equal to displaced volume of seawater. So this is the concept. Okay, so now as I was discussing like that, so this was the concept, but your buoyancy force is equal to the weight of the block, or you can say the volume, how much volume is displaced. So weight of the block, how you will calculate? So weight means what? As you know already, what is weight? Gamma is equal to weight by volume. So your weight is equal to gamma by gamma into volume. And what is gamma? Rho g volume. So volume is how much? So volume is area into height. So how much area? Okay, area is not given, but height is given already. So how much height? Height of the ice, that is 5 above the sea, and beneath the, we have considered HBB, whatever we have considered this one. So in the solution it is given H. So we are considering H, remember H. So this is the volume. So weight of the block is rho g and the volume. And what is your buoyant force? So buoyant force is equal to what? The displaced volume, as I have discussed already, as I have already told, the displaced volume. So how much? Rho of water that is rho of water 1000, or sea water here is so 1028, and your volume of water is how much? Volume of water is displaced, so only this much volume is displaced, not all. So this much is displaced means what? So height is h only, and area is area of ice. So here area and area is same, so that's why I am writing area, and area of ice and height is h. So your buoyant force is equal to what? Buoyant force is nothing but it is the displaced volume of water. So displaced volume of water will be equal to the weight of the block. Remember please, very important questions. So let us suppose you have one, let me just finish, then I'll discuss some fundamental. So yes, the equation will be rho of water g, that is your buoyant force, or you can say that displaced, this is your displaced water, weight of displaced water is equal to weight of the body. So weight and weight, both side is weight. So after the calculation you will get, so AA will be cancel out and H plus 5 and this one, after that you will get 13.35.16, very important one. So 35.16, this will be correct. Now in the general way I want to talk you, let us suppose one, this is filled with, completely filled with water. Once you will drop, let us suppose you have one ball, once you will drop this ball, the water will be out from here, and water will be out, and as you will drop the ball here, it will be look like that. Let me just redraw for you guys. If the ball is, if the your ball density is less than your water density, so little bit above, so ball is like that, and here water will be some out, so some water on the ground, let is some water. So when you will weight, so weight of ball is equal to this water, the weight of this water will be equal. You can experiment in your home also. At the place of ball you can take another things. So remember please, so there is no need to remember these things, your the buoyant force and the weight of the block. So always remember, if you have one full bucket of water, if you have the full bucket of water, once you will put anything, so similar weight of water will be ejected from your the bucket. So always remember. So that's why here we have the consider the weight of displaced water will be equal to the weight of body. This is a simple Archimedes principle. So always remember. If you sometimes what happens, people forget about the Archimedes principle. What was the Archimedes principle? But the one thing is, remember always whatever I have just told you here, the experiment. Remember these things. The weight of the body will be equal to weight of displaced your water. Sometimes what will happen, let us suppose you have the this much bucket and water is up to that only. Once you will put the ball, what will happen, the water level little bit increase, because water level bit increase. Here water will not go outside because your this bucket is not completely filled. So somewhat what will happen here, or some water depth will be increased. So water depth is increased means what, the change in the volume, the water of the volume is increased. Water of the volume will increase how much, is equal to the weight of the water of volume increase. Water of volume increase how much, the weight of the your ball. So weight of the ball and divided by weight of the volume increase. So weight of the volume increase means row of water into area of the bucket, surface area, and the height increase, that is h, is equal to weight of the ball. So row of the ball. So like that you just try to think yourself and try to draw the figure what I am drawing on the your for you. You just try to draw on the your paper, your copy, then you will think on that. This is very interesting and very, you can expect the question, such type of questions in your exam, final exam, or in your gate exam also, very important. So now the next question is, the barometric pressure at the base of a mountain is 750 mm Hg, and okay, I'll take 5 minute break. So if anyone want to take 5 minute break, you can go. Otherwise you just read the question and try to solve the question and write your answer in the chat box. So I'll take 5 minute break. Okay, Nitish is telling option B is correct. That is 2000. Okay, other student, please also, if you want to write your answer, you can write. Otherwise, let me just read the questions. The barometric pressure at the base of the mountain is 750 mmHg and at the top 600 mmHg. If the average air density is 1 kg per meter cube, the height of the mountain is approximately. So let us suppose you have mountain like that. So you have mountain like that. Okay. So now at the base of the mountain was your pressure is barometric pressure 750 mm of Hg. Here at the top 600, let me write here B for bottom and T for top, 600 mm Hg, and air density is given 1 kg per meter cube. So you have to find out the height of the your mountain H. So this is the question. Now I'll give you 1 minute or 2 minutes for other participant. Just try to write your answer. Very easy question. Okay. So let me just show you the answer. So here is the answer. The pressure difference is how much? Why 150 or 750 was there? So pressure difference is this much. And what is your pressure difference? So delta P is equal to P bottom minus P top is 150 mm of Hg. And what is delta P? Delta P is nothing but rho g H. So you need H value. So how much H? Your delta P 150 into, for mm you will write -3 for converting in the meter, and for the Hg you will write 36,000 and 9.81, and then after GH. Rho g, because h you need to calculate. The rho of the water is given, water not, rho of the air is 1 and g is 9.81. So after calculation you will get 2040 meter. So hope everyone got it. So is there any answer? Oh no, answer is not. So you go with the most appropriate option. So yes, the 2000 will be correct. So hope everyone got it. Yes. Now the next question is, okay, if everyone got it, the previous question, you just try to write in the chat box yes. So I'll move on the next question. Please everyone. Just to write in the chat box yes or no. If you're not getting, then you can also write no. I'll discuss again. So please, everyone, please write yes at least. Okay, other student, please also write. Because this session specially arranged for you guys. If you are not able to understand, there is no meaning for this such type of sessions. Okay, Alam is also telling yes. Okay, good. So now we'll move. Now I can move on the next question. Next question is a U2 with both limb open to atmosphere contains two immiscible liquid of density rho 1 and rho 2 under equilibrium. The distance h is given by, this distance h is given by which formula? That is the which option? A, B, C, D. A is about h is equal to L1 minus rho 1 by rho 2. B is h is equal to L1 plus rho by rho 1 by rho 2. And C is h is equal to L divided by rho 1 by rho 2. And D is h equal to L1 minus rho 1 by rho 2. Which option will be correct? So please everyone just try to solve. You have 5 minutes for this question, very important question. So yesterday we have also discussed such type of questions. So hopefully you will get the answer for this question. So everyone, please within 5 minutes just try to write your answer. Please everyone just try to write your answer in the chat box. Okay, Nitish is telling D option. L h is equal to L 1 minus rho 2 by rho 1. Other student, please also try to write. Please everyone just try to participate. Okay, Pramod is also telling D option. So let me just write the answer. So this is H, and if you will draw one line here, and if you will draw a line here, so this height will be your H minus L, L minus H. So if this is rho 1, what you will write? The pressure of the atmospheric pressure, both side you will write the atmospheric pressure because both limb is open. So will neglecting, I am going to neglect here. So rho 1 into G into height, this much height, L minus H is equal to, from here, rho 2 G L. So now you need to calculate your H. So G will be cancelled out. Rho 1 divided by rho 2 L, minus H is equal to 1. So you need H. So what you will do? You will try to rho 2 L divided by rho 1, here L minus H, and H is equal to rho 2 L divided by rho 1, that is L minus this will be, the H will be is equal to L minus this. If you will take L outside, what will be remain? 1 minus rho 2 by rho 1. This is H, not L. So yeah, this is correct. So option D is correct for this. So hope everyone got it. If yes, please write everyone yes in the chat box. Everyone please write in the chat box yes. Okay, good. Already some student already solved, so that's very nice, and I am appreciating. But if anyone not able to solve, and if you are getting something, okay, good. So now we can move on the next question. Next question is, when a ship enters the sea from a river, it rise a little, sink a little, remain at the same level, rise or fall depending of the material of the ship.
The previous answer, sir. One second.
This one, the option D.
L,
Once
L
one,
into 1 minus rho 1 by rho 2 by rho 1. Okay, sir.
yes. Should I explain again, or are you able to understand?
No, sir. Okay, sir.
No need to explain. Okay. So let us move with the next one. This one. So when a ship enters the sea from a river, it rise a little, sink a little, remain at the same level, rise or fall depending on the material of the ship. Which option will be correct? So please everyone just try to write your answer in the chat box, or you can interact using your mic also. So here again you think about that, the your Archimedes principle and density of water, density of sea water, density of river water. So if you will think, hope you will understand. Hope you are able to give the answer. Okay. So both two students, Nitish and Alam is telling, Nitish is telling D and Alam is telling A. Okay. Other student, please also think on that. Very important questions. Bit tricky. First, you just try to think why something is, why something is not.
Option C.
Option C, remain at the same level. Okay. So first you just try to think on that, why something float on the water, or why something sink in the water. The reason behind it in terms of density, if you will understand, then you can easily able to give the answer, correct answer for this question.
Due to a specific gravity, sir.
Yes, you can say specific gravity or density, you can also say.
Yes, sir.
So if let us assume, if you have one paper and you will put in the water, so it will float, not completely, but after sometimes after the, when it will saturate and all, then it will be sink, but initially it will be float, because of the density of water is density of your, or at the place of water will take some polythene, the polythene will float on that. If you will take iron, iron will be sink out. Why? Because the density or a specific gravity, if you are saying the difference. So as you know, river water specific gravity and the, let me just hint you, the density of river water and the density of sea water, the relation, option A is this one, option B, I am writing the R and S. Oh, let me just say it's S, option C equal, option D none. So which option is correct? First, please everyone tell here. Which option is
A.
correct? The relation between A.
Answer A is correct.
Someone telling A. Okay. Alam is telling A. Other student, please also you can comment which option is correct. Okay. Nitish is also telling A. So let me just take one, two container, and in one container I want to put river water, and here I want to put your sea water. So let me just drop the same things. Let us suppose I am going to drop here a ship which made by plastic, some material, and here also I am going to drop, or let me just draw in another way, so hope you got it. So here I have one ship, the plastic ship. So when you will put in this ship, what will happen? In which water your ship will sink more? Sink more in which? Whether in R and whether in S. Sea water. In which water? Of course, the density of the plastic is less than your sea of river, that is the density of river and density of US. So in which little bit sink, but in which one? Which one will sink more or rise? The option is about the rise and sink, okay, or at the same level, and rise or fall depending on the material of the ship. But here we are talking about the same ship in the river and in the sea. We are going with the same ship. So here there is no meaning of the material, because of the we are going in the river and the sea with the same ship. But in this question, what will be the correct answer for this question? I'll show you later, but just try to think on that. So in which water your, okay, Nitish is telling R, that is in river water, okay, and in the sea water will sink less. One thing for another student I want to tell you, the if density is more, rho s, if density is more than rho water, so let us suppose with the same force, if you want to remove anything, what will happen? With the same force, if you want to remove anything, so this will remove less. Let us suppose you have something like that and something like that, and the density is, here is density is 10 and here is density is, let us suppose 8. So when you will try to remove these things, this will be like that, this will be like that. But with the same force, let us suppose you are applying here 120 force, and if you will apply here 120 force, this is, but this is having 10, so this volume will be changed less, because of the it's having the density, that is the more strength. So I am talking about this. So once you will put the same ship here, this having the less density and this having the more density, so in which the water level will increase more? In the sea, in the river water, height will be increase more than the your sea water. Sea water height will be, the height increase in the your this bucket will be less, because of the density having the more, but very small, because density, as you know, very, the for water, river water is 1000 and for this 0.28. But here the concept is this, the concept is, that is, it will be the negligible, but the concept is, so this was the concept is, once you have the denser fluid, so when you will put the same thing in the denser fluid or the lighter fluid, so denser fluid will displace less compared to your this one, or meaning, if the less displaced means it will be little bit less sink than your river. So now hope you will get. So I think when you will from entering from river, so when you will enter from river means you are entering from lighter fluid to denser fluid. When you will enter from lighter fluid to denser fluid, so hope little bit increase, not decrease. So let me just show you the what the explanation is given. What explain? Yes, here is the rise up. The ship will be rise. So hope you all got it. If yes, please you can write the answer in the chat box. You can write yes also in the chat box. So this is the concept. Okay, fine. Okay, so you can apply such type of concept in your exam also, or in another questions also. Not for this particular questions, so you think like that. If something is lighter, definitely when you will apply the same force or you will put the same thing, definitely it will expand more compared to the heavier things. So let us move with the another question. So question is the hydraulic lift is based on which of the following? Bernoulli's principle, Pascal law, Archimedes principle, or the Boyle's law? We are
C.
talking about here hydraulic
C. C.
lift. C, you are telling this, you are telling C, okay, Archimedes principle. Other student please also try to write. Just please think on that, what is Archimedes principle, what is Pascal law, what is Bernoulli's principle, and what is Boyle's law. Then very you are able to give answer, correct answer. One student is telling Archimedes, okay. Other student please also. And Nitish is telling Pascal law, okay. Gulshan is telling B. Yes, rise little, yes. So for previous question, yes, definitely little bit rise because you are moving from lighter to denser fluid. Uh, okay.
Option B.
Option B, okay. Shiva Shankar Prasad is telling option B, Pascal law, okay, good. Alam is telling C, Archimedes principle. Anyone? Anyone else? So for this actually I have one figure also, so I'll show you figure. So one student is telling C, so what is Archimedes principle? I was just previously discussing. Archimedes principle is nothing but the buoyant force is equal to the weight of displaced volume. But here we are talking about the hydraulic lift, not such kind of things. So definitely Archimedes principle will not correct. So the correct answer will be the Pascal law. How? What is Pascal law? As as you know already, one question in the initially I was just try to show you very important questions. This one means if you have the pressure P here, so at the same level at anywhere in the fluid, if the fluid is same, at the G your pressure will be P. Remember, your pressure will be P. Means at a particular level, everywhere in the fluid pressure will be the same at the same level. So using this concept and the pressure, you know already what, force by area. So pressure is inversely proportional to area. So you can do one thing. What you can do? So when you will reduce the area of something, when you will reduce the, initially suppose that area was this, but after reducing the area is this. So P here, let us suppose PA and PB, in which case the your pressure will be more, whether this condition is correct or this condition is correct. PA, which condition is correct, A or B? Just please try to think, write your answer, because here the inversely relation, if inversely relation area will be reduced then pressure will increase. So definitely your option B is correct here. Option B is correct here. So meaning, if you want to design a hydraulic machine, what you will do, let us, I will apply force. Here I am going to apply the force, and I'll connect this thing with a very small, okay, and here I want to lift something. Suppose that I want to lift something, some block. So this is one condition. Second condition is just opposite. Second condition is just opposite. You will apply force on the small pipe and you are going to lift with the bigger one. So here again I'll ask one question. So here I am applying the force, same force, F here. Here also I am going to apply F, and this is your same body. This is your same body, same block. Not same block. This, suppose that something different, and this is something different. So here the question is, which machine is able to lift more force, the more weight? This is W1 and W2. So here my question is, W1 greater than W2, option B, W2 is greater than W1. Which option is correct? Just think on that. You are applying the same force in both conditions. We are going to design a hydraulic machine. We are applying here the same force, and here is liquid is filled. Remember, in the pipe liquid filled. Why liquid I am filling here? Just think on that. As per the Pascal law, if you will apply the force here this much F, the similar force will be act here, because this force is connected, because liquid is connected throughout. As per the Pascal law, you know already, if you will apply force here, the similar force at that same level is this, similar will be. So what is force? Force is your pressure into area. So if you are applying here, okay, Nitish is telling B option. Okay, let me just show you. So if you are applying force here, so this force is much. Here we will calculate the pressure, not force. So pressure here, at that level your pressure is force, you are applying the similar force, force by area. So here pressure is very high compared to this, because area is less. If area is less, pressure is high. So here pressure is high, here also pressure is high. Here also pressure is high, remember please. Here pressure is high, here also pressure is high. Here pressure less. If you are applying the same force, the pressure will be less. Here pressure is high at that level, and here pressure will be less, because area is, because pressure is what? Force by area. Similar force you are applying here. If you are applying 10, here also you are applying 10, but area is here high, so here pressure will be less. If the pressure is less here, then here also pressure will be less. But one thing remember, the pressure will be less means what? Whatever the pressure here will generate, the similar pressure here will be generated. But you know already, the pressure is force by area. But as you are reducing the here area, here two things will work. Here you are changing area also. So as you will reduce the area, what will happen? The force by area. As you will reduce the area, the force will be more in this case. Force will be more. and here the force is, you have the same pressure but force is P by area, P into area. Area is more but force will be less. Force will get reduced in this case. So you always go with such type of design. So for that, one, no, for all, here what will happen, yes, for always you will go for such type of design, as here is mentioned here, how lifting a large weight by a small force by the application of the Pascal law, a common example of the hydraulic jam. So how here is given already, here area is A2 and P is, but the force is what, pressure into area, and here force is the P into A. So you are applying a small force, but here the, as your area is increased, your force will be increased. One thing remember, the pressure at that level, pressure at that level and pressure at that level, as per the Pascal law will be same. If pressure here is P, the pressure also here will be the P. But the force is the game of what? If the two things is, if the two place your pressure is constant, the things is about the area. As area will increase, the force will increase. So here area we are reducing and here area is increasing, means force we are increasing. Area increasing means force increasing. So we will apply here the small force. By applying the small force, we want to get the more force. So if you want to get more force, you want to increase the area of this. So we have increased the area and we are getting the more force. So remember these things, very very important. So hope everyone got it, the concept behind it. So everyone got it? If yes, please just write your answer in the chat box. Just you write yes. So this is the concept. Anyone have any doubt? If not, please you just write the yes. Okay, fine. Now let us move with the questions. We have already solved. Okay, here example is given already. So this is the last question for today. So the next Tuesday in the same time we'll discuss more. So let us solve the last question. A beaker, a beaker half filled with water is exposed to atmosphere. Okay. If the pressure at point A, B, C, as shown in the figure PA, PB, and PC respectively, which one of the following will be the relation connecting? Anyone want to say? Okay. Connecting the three. Which option is correct? And option D is this. So please think on that and try to write your answer. Nitish is telling A, okay. Alam is also telling A. Other student, please also try to write your answer. This is the similar question like the previously I was showing this question, as I have discussed very detailed. Where is this one? As I have discussed in very detail this question. So similarly, you just think what I was discussing, the here and the if the water level at the height, how your pressure depend on height and your density of fluid. So similar thing is given. So just you try to think on that and try to write your answer. Where is the yes, this one. So you have 1 minute more. So anyone want to say, you can write. After 1 minute, I'll explain how which relation is valid. Okay, Shohan is telling A option. Ramdan is also telling A. Okay, everyone telling A. So hope A will be correct. How? So you have the box like that. Half filled with water. So this is below, not up to that. You just think the level is same. So one point here you have and another point you have, B and C at the same level. So you know already your pressure is rho GH. So here rho is constant. For this particular case, your pressure is the function of what? Only H, because rho is constant, because water is given already. G also constant, you know. So function of H. So let us write PA. PA is what? Rho G H is 0. So this will be 0. PB, we are calculating here the gauge pressure. Remember, we are not counting the atmospheric pressure. PB. So rho G, and this will be the, if suppose this height is H or H1, or yes, capital H I want to write here. So H is capital H. Similarly for C, rho G, this B and C the level is same, so capital H. So rho PB is equal to PC, and both are greater than PA. Yes, so it is written like that, PA both greater than PB is equal to. So hope you all got the concept. So if everyone got, just write yes. So we'll meet in the next class on Tuesday, the same time 7 to 9. So everyone please just write yes if got it.
So from where we get a PDF from all the questions?
So you have registered for the fluid mechanics already, no?
Yeah. I have already registered, sir.
Okay. So if you have registered, so you will get, I think.
The previous class, I don't get. That's why.
Okay, let me just show you. How you will get, let me just show you, right? So initially what you will do, for everyone, just I want to show you one. So if everyone got it, just I am going to answer this one. Stop presenting. Okay, for you guys, let me just share my this screen, the Chrome browser. Yeah, it's visible. Now it's
Yes, sir.
visible, right?
So,
So what we will do, let me just keep it this side. So we will write the fluid mechanics, your NPTEL. Online courses. In all courses, you will go here. Oh, it's not visible, I think.
yes, sir. No visible.
Oh,
It's not visible.
now stop presenting. Yes. Now it is visible, right?
Yes, sir.
So what you will do? Let me just go back. You just write NPTEL SWAM, right? And you will
Yes, sir.
go for NPTEL online courses, all
Yes,
courses.
sir.
In all
Yes, sir.
courses, you will find your fluid mechanics one.
Yes, sir.
Site is bit slow. So in between, let me just upload the today PPT. It is open. Yeah.
Yes, sir.
So now what you will do? You just search your course and here you just sign in. So using your Gmail and whatever you have already using the, so it is already open, I think. So here you will get problem solving session. It is visible.
Yes, sir.
And problem solving session recording. So you will go through this. For recording you will click here and then you will click here and then you will get everything.
So
For
it
one,
opens only Excel files, sir. How to use it, I don't know. I already tried, so
no, Excel file is open already.
yeah.
Yeah. So let me just show you what is opening. So I think
So
it
I
will
don't
be,
understand how to use Excel file, but
yes. This is open.
Yes, sir. Yes, sir.
Yes, so what you will do, just click on that. You will
Yes,
get
sir.
this one, this file, and after you just click on that and you will get the everything. Right?
Okay, sir.
It's not visible, I think. Let me just share the entire screen, then you can. Screen 2, not screen 1. So what you will do, just go back. If Excel is this one open,
Yes, sir. Yes,
so
sir.
this is for my Om Prakash Maurya. This is another student, three student is just teaching. So let me just open for another one. So you will get these things, right?
Sure,
So
sir.
what you will just double click on that and you will get everything. From here you can download and read. Okay.
So I want to know, sir, just know, fluid mechanics or advanced fluid mechanics, both are same or different?
No, no, no. If the professor is different, how it is same? No, no.
Okay.
You can go through the content. I think the difference,
Bo-
the
Both
sub.
the classes conducted together, sir. Advanced or your class. The timing is same. There is only 1 hour difference. That's why I was late.
Okay, okay. So it is different. Yeah, definitely difference. Not same. So hope everyone got it. And for
So,
me, I have already uploaded the second one. If you will click here, you will find week 2 I have already uploaded, right?
so,
Once you will click, you will get. I have lot of questions. I have given lot of questions and concepts. So everyone please go through that.
so,
Because I am teaching this the fluid mechanics last 3 years. So I have lot of content and questions. So everyone please follow these things. Okay, hope you all got it.
so.
Okay, thank you all. We'll meet again in the next class.
Thank,
Thank you.
thank
Bye
you,
bye.
sir.
Okay.
Thank you, sir.
Okay, thank you. Thank you so much.